In this lecture, we're going to discuss section 7.4 that talks about other trigonometric functions. So let's draw our attention to the other functions. So far, we've talked about sine, cosine, and tangent. The other trigonometric function, well, we really focus on sine and cosine, not so much of tangent, but the other functions are tangent, secant, cosecant, and cotangent functions. We kind of did discuss tan. Tan was y over x. However, secant, sometimes abbreviated SCC, is equal to 1 over x. Cosecant, usually abbreviated CSC, is 1 over y. And cotangent, usually abbreviated COT, is x over y. We also call these the reciprocal functions because secant is 1 over cosine of t, cotangent is 1 over tan of t, and cosecant is 1 over sine of t. So if you notice, these are all reciprocals of the functions that we had before. Okay, so now let's say we are given an example where we're asked to find sine of t, cosine of t, tan of t, SCC of t, cosecant of t, and cotangent of t. So recall that sine is going to be the y for your coordinate. So that's just going to be 1/2. Cosine of t is going to be the x for your coordinate, which is going to be -√3 over 2. And tangent of t, well, that's sine over cosine. Which is going to be 1/2 over -√3 over 2. And we know we do keep, change, flip. So this becomes -1 over √3, but we don't keep square roots in our denominator. So this is really √3 over 3. Negative. Okay. And so we only did the first 3. We want to do SCC of t. Well, recall that SCC is 1 over cosine of t. Again, cosine is going to be my x, so that's going to be 1 over negative. Really, all you're doing is reciprocating. So this is going to be -2 over √3 because, as we said, it's the reciprocal function. So you just reciprocate cosine. Cosecant is the reciprocal of the sine function. And the sine function is 1/2, so let me just write that. So this is going to be 2 over 1 or just 2. And cotangent of t is equal to the reciprocal of tan, which is going to be cosine t over sine t. And so cosine is -√3 over 2 Actually, let me see. Yeah. Negative root 3 over 2 divided by sine, which is 1/2. Keep, change, flip. So it's going to be negative root 3. So in just knowing your coordinate, you can figure out each of your sine of your trig functions. Let's try one more. So again, sine is going to be my y. Cosine is going to be my x. Tan is going to be y over x, or sine over cosine. Anything divided by itself is 1, so that's going to just be negative 1. So if we want to figure out now secant of t, that's going to be 1 over cosine, which is really, we're flipping this, right? So it's just going to be 2 over root 2. We don't keep our roots in the denominator, so it's 2 root 2 over 2. Okay, next let's look at cosecant, which is 1 over sine, or you could just flip sine. You get your answer. And cotangent is going to be cosine over sine. Also negative 1. All right, next, let's say we want to do the same thing, but with an angle that is in radians. Okay, so nothing will change really. What you could do is just find your coordinate for this function here, or this angle. Pi over 6 is going to be your 30-degree angle, right? And for pi over 6, your coordinate is root 3 over 2 1/2, right? So that means sine of t is going to be 1/2. But yeah, Sine of t is going to be 1/2. Cosine of t is going to be √3/2. Tangent of t, that's going to be sine over cosine. That's going to be 1/2 okay. SEC of t SEC of t is going to be 1/cosine, which is just flipping that, you'll have 2/√3. CSC of t is 1/sine, which is 2. And cotangent of t is going to be 2√3/2 over 1/2. Keep, change, flip. So we have √3. Alrighty, so there's something that we want to note about the other trig functions. Well, all of the trig functions, the 6 trig functions. In the first quadrant, all functions are positive. All of the functions are positive in the first quadrant. In the second quadrant, the only functions that are positive are sine and cosecant, and of course cosecant because it's the reciprocal of sine. In quadrant 3, the only functions that are positive are tan and cotangent, because of course they're reciprocal functions. And in the fourth quadrant, the only function that is positive is cos and secant, cosine and secant. And we have an acronym, all students take calculus. This is not true, right? But students for sine, take for tan, and calculus for cosine. So for a question like this, where we need to use the reference angle to find all 6 trig functions. So first we need to figure out, well, what is the reference angle? Hopefully we remember what the reference angle is. If we were to draw this angle, -5 pi over 6, just in case we still don't know these by heart, which I hope we get a chance to. So this is going to be negative 150. And so remember, we go in clockwise position, clockwise. So the reference angle in the third quadrant is going to be 180 minus 150. So this is going to be 30 degrees. So my reference angle is actually pi over 6. And so, to be honest, we can just go to the example we just did for pi over 6 and use this information. So I'm just going to copy and paste. Let's see how this works out for us. I really only need the answers. Okay, and then okay, and thinking of the fact that we're in the, what is this? The third quadrant, we have to think the fact that both of these signs are going to be negative. So sine of t is going to be negative 1/2. Cosine of t is also negative. But if you take the negative times divided by the negative, you're going to get a positive value for tan. So that's good. Secant is 1 over sine, so it's going to be negative. Cosecant is also going to be negative 2. And cotangent, well, sine over cosine, both negative, is going to be positive. So when we're using the reference angle, it's very important for us to determine, well, where is the angle located? So we can put the appropriate signs. So we have a set of identities called the even and odd identity. And so, well, we can really, okay. So when we talk about even and odd, we're talking about functions that are symmetric. So for even functions, that's going to be functions that are symmetric with respect to the y-axis. For instance, parabola, you see, the y-axis serves as a mirror. So all of the trig functions that have graphs that are like this are considered to be even. And these functions are cosine and secant. So what that means is cosine of negative theta is equal to cosine of theta, and secant of negative theta is equal to secant of theta. Additionally, we have odd functions. For the odd functions, these are symmetric with respect to the origin. So for instance, if we recall x cubed, you see that it's symmetric with respect to the origin. And these functions are the remaining four functions. So if you want, you could just study that that cosine and secant are your even functions, and then everything else is odd. So for instance, let's say we're told that secant of angle t is 2, and we want to know what is secant of negative t. Well, since secant is a even function, so secant of t is going to be equal to secant of negative t. So if this is 2, then this is also 2. So there are some identities that are very important for us to know. Of course, there is this one that talks about, well, we kind of discussed this earlier. For tan, it's going to be sine theta over cosine theta. For secant, it's 1 over cosine theta. For cosecant, 1 over sine theta. And cotangent is 1 over tan theta, which is also cosine over sine. All right, so for instance, let's say we're given that sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. If we want to evaluate tan of 45, well, we have to utilize the fact that tan is what? Sine theta over cosine theta. And so this is going to be, it's the same thing. Which is just going to be 1. Okay, so for example 7, I'm going to change this example to something a little bit more challenging. So let's say we were asked to simplify. Let's say we're asked to simplify secant of t divided by tan of t. Because sometimes we're asked to simplify trig functions, and it makes the whole difference if you know your identities. All right, so oops, what's going on here? Let me see. Okay, we're just gonna leave it like that. All right, so think about it. Secant. So we have secant of t divided by tan of t. So recall that secant is 1 over cosine of t. Tan is sine over cosine of t. So keep, change, flip. These would cancel. So I'll have 1 over sine of t, but we know that 1 over sine of t is actually cosecant of t. So that would be my answer. So it's very important to know your identities so that you can solve for or simplify different terms that involve your identities. All right, so we'll stop here for today and pick up on next class. All right, have a great rest of your day.